Okay, so I'm going to show you how problem 1, we arrived at our solution. So Marina has been really busy. She wants to make her pond larger, and her pond is cone-shaped, right? So we've drawn a picture of a cone, or you have a picture of a cone here. And the radius, right, the original radius is 30 meters, right? So note that that's 30 meters. And it has a depth, right? So its height is 15 meters. Okay, now she wants to increase that, right? So we want to change that. Let me put an R here. So our new R is going to be 40 meters. And our new height, she's got to dig deep now. She's got to get down another 5 meters. So she's going to be calling her best friends here to start digging for her pond. And then the question says, how much more water will the new pond hold? Right, so we're definitely talking volume here. One of the most important things about doing this problem is what I've given you this little clue. Don't round your numbers until the very end. Okay, so since we have a cone, if you go to your reference sheet, right, and you should go to your reference sheet, don't use your memory, all right, you look up the formula is volume equals 1/3 pi r squared h, right? Because our circle, right, area of a circle is pi r squared times the height. That would be a cylinder. But remember, this goes into an apex, so you're only taking up 1/3 the volume that a cylinder would have, right? Okay, so when I look at this, I simply go, all right, so I have the original, right, over here, and I'm going to go, well, okay, the volume of her original pond is 1/3 pi. The R is 30 squared times the height of 15. Okay, so what I'm going to do here is pick up my calculator, right? And 30 squared, well, we can do that in our head, is 900, but times 15, right? And then 1/3 of that is dividing by 3. So what I like to do is leave this in terms of pi, right? Because they're both going to be in terms of pi. And when we go to do our subtraction, right, then we don't have to round decimals. I don't have to write out this big long decimal. So it's really convenient to leave it in terms of pi. Okay, so now we have the dimensions of our new pond. Okay, so those, right, I'm going to use the same formula, 1/3 pi. My R now is 40 squared, and my height is 20. Okay, so I'm going to do the same thing, 40 squared, 1,600, times my 20, right, 32,000, and I'm dividing by the 3 because that's the same as multiplying by 1/3. This one doesn't come out as nice, but it's okay. 10666, and 0.6 repeating is really the fraction 2/3, but it would be okay if you just wrote the big decimal. You'd get the same effect anyway in your calculator. Now, to finish the problem, right, the problem is saying, well, how much more water does it hold? Like, what is the difference between, right, the 4,500 pi and the 10,000, right, almost 667 pies? So now, to finish this up, we have to subtract, right? And that's where leaving it in terms of pi is very nice, right? So if we have 4,500 pies, oh, I'm sorry. I did not want to write that one first. I want to write the other one first. Okay, so if we have 10,666 and 2/3 pi, and again, you could have left that as the decimal, minus the 4,500 pi, right? So if I go minus in my calculator, 4,500, right? What I have here is 6,166 and 2/3 pi. Now it is safe for me, right, to take that decimal in my calculator and multiply by the pi, right? And it does say round to the nearest cubic meter. So the volume, right, is 19,373 cubic meters more. So she is going to have room for plenty of more fish. All right, so I hope that explains that and you understand that now. And if you're going on to the next problem, you won't make the same mistakes if you made those mistakes. All right, Action Jackson, signing out. Cause with all that has happened, I think that we both know the way that the story ends. Then only for a minute, I want to change my mind, cause this just don't feel right to me. I want to raise your spirits, I want to see you smile.